I'm Andre Fredette from Red Hat's Office of the CTO. In this video, I'm going to walk you through Planner, a tool that helps you go from business requirements to a deployed LLM inference solution. Planner has recently become part of the llm-d project. So getting an LLM into production means choosing the right model, GPU, and configuration to meet your performance and quality goals. The number of combinations is huge, and finding the right one often turns into a time-consuming and expensive trial and error process. Planner simplifies that process. It takes your business requirements and turns them into concrete, actionable recommendations so you can get to a working solution much faster. So let's get started. So we start here in describing a use case using natural language. In this case, I'm saying I need a customer service chatbot for 300 users. I'm specifying some GPUs that I'd like to use that perhaps I have available, as well as some models that I'm interested in evaluating. And I'd like to keep the cost down. So once we describe the problem, we click Analyze the Use Case. So this uses a small LLM to extract the important information from that description. Once that's done, should evaluate what was extracted, make sure it's correct. You can modify it if you want to. If it's okay, you click Generate Specification. Before I do that, I'll just mention we also have some buttons here that have some sample scenarios, descriptions of use cases that you can use just for testing or to kind of start out your description. Okay, so this looks good to me, so I'm going to go on to generate the specification. So here's where we based on the description, we build a specification that describes what the system needs to do. And this involves SLO targets, so what kind of latency requirements you have for the particular use case, the workload profile, the throughput, and the traffic input and output sizes, a set of accuracy benchmarks that we'll use to evaluate the solutions, as well as the user priorities. So these are all built from some profiles that we've put together for different use cases that describe these typical requirements. The user you can go in and change some of these if you want to. Once you're happy with them, you can click Generate Recommendations. So the recommendation process involves a number of steps. First, we base it off of two different sources. One is a database of benchmarks that have been built, and the current one I'm using has been built with Guide LLM for a range of models, GPU types, and configurations, different levels of tensor parallelism, and for different data profiles. So we'll find the solutions in this database that satisfy the performance requirements for the given data profile. The other source we use is some estimation tools, which are shown here on left-hand panel, the capacity planner and GPU recommender. So for combinations of models, GPUs, models, hardware, and data profiles for which we don't have actual benchmarks, we can do estimations to fill in the gaps. So once we get the set of options that satisfy the performance requirements, we'll go through and score and rank them on 3 different dimensions. Currently, we're looking at some others for the future, but we rank them on accuracy, based on accuracy and quality benchmarks, cost, based on some cost data we have, and latency. And then there's a balanced solution, a balanced ranking that combines the 3 according to the priorities that you've laid out. So for these, each of these categories, we give you the top 5 options. You can look through them. We tell you whether they're come from the benchmarks, so that we've actually run this on the GPUs and have that real world data, or the or they were estimated. So once you decide which to choose, you can select it, and when you do this, it builds deployment files that can be used to deploy to Kubernetes. In this case, for on Kserve, an inference service file for Kserve. So you could download those and deploy them yourself, or if you're connected to a cluster, you can use the planner can deploy it with this button. So I'll do that in a minute. Before I do that, I'm just going to mention what the kind of cluster I'm using right now. This is a kind cluster that's currently just running on my laptop. And for this kind cluster, we have a VLLM simulator, which is useful we use it for testing. But it can also be useful just to try out the deployment. And you can see we have Kserve running. Currently, there's actually one solutions already running that I had deployed earlier. And then the Kserve components. So back to Planner, I can go ahead and deploy it. And when it's deployed, I can go to the Deployment Management tab, which will show the deployments I currently have running on the cluster I'm connected to. This is the one that was there. This is our new one. Do a refresh. It's ready now. This page will show you different information, some status information about the deployments, and then also has a testing tool that you can use to send prompts to the LLM and just to test out, make sure it's working right. You can get some data on it. In this case, this is using the simulator, so it's not really running an LLM. It just responds with some random prompts. But if you're connected to a real cluster, this would be a real test. And then I'll just go back to the my cluster, take a look, and now I have this new chatbot deployment running. All right, so that is the end of this demo. In this down below, you'll see links to both our repo and our Slack channel. Feel free to reach out with any questions, comments. Take a look at the repo for the documents and code for more info. And you're welcome to join in and help if you're so inclined. So thank you for watching.